Hi friends, good day to all. In upcoming sessions, we're going to look the analysis of various beam with different load condition. So the different loads are point, UDL, UVL and moment loads. So in this current session, we're going to discuss the point load acting on the cantilever beam. For the point load acting on the cantilever beam, we're going to find out the shear force diagram, bending moment diagram, and what is the maximum deflection of the beam for the point load act on it. Let's see the PPT. So this is the problem statement we're going to look. A cantilever beam of length 3 meters carry the point load as shown in figure. So we need to draw the shear force and then bending moment diagram for the cantilever beam. So in our strength of material class, we already discussed with mathematical formulas to derive the shear force and bending moment diagram. In this session, we're going to look to derive the shear force and bending moment diagram through Ansys FEA simulation software. So the image you see on the screen is the cantilever beam with point loads which is located on the three different locations. So we need to discuss. Okay, so this is the mechanical APDL product launchers. So for getting the shear force and then bending moment results, you need to change the high performance computing setup. So from whenever you install the software, it will be in use distributed computing type of computing setups. So you need to change it to shared memory parallel setup to get the shear force and then bending moment results. So you need to open the directory where your files need to be stored and give the job name cantilever beam with point load and give run. And then go to file, change the title of your analysis. So this is the cantilever and it is a point load, and then just give OK. And then next go to preference, and this is the bending moment analysis. This come into the category of structural, give structural OK. And then we need to choose the element to divide the beam into n number of small elements. So what kind of element we going to choose? Go to preprocessor, element type, add it, delete, add, and then beam. So normally we uses 2 node 188 which has the 6 degrees of freedom, generally preferred for all kind of beams. Problem analysis, give OK and then give close. Next we need to define the material property. So here we don't need to generate the real constant. So here we have the separate 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 tool to identify the moment of inertia by using the sections. So we're going to define the material properties without using the real constant. Go to material properties and then material models and then choose structure, choose linear, choose elastic, choose isotropic. So this is the normal speed and its Young's modulus is 2 into 10 to the power 5. Just give 2 into e to the power 5 and then proximity ratio is 0.3 and then give OK and then close it. So next we need to define the cross section of the beam. Go to section, go to beam and give the common section, and then here you need to enter the cross section of the beam. The breadth is 200 and then height is 300. Okay, just give the value. Wait a minute. So go to sections, beam, common section and enter the value of breadth is 300, and then here you can give the ID number is 1. Here don't need to change, and then this is the various cross section of the beam. So the cross section of our beam is rectangular cross section. Choose the rectangular cross section and the offset type is centroid, and then breadth of the rectangle is 300 and height of the rectangle is 200. And then you need to measuring the volume of the beam by giving the NB and NH value. I want to divide the segment into 10 segment of mesh. So give 10 at 10B and give 10 at NH and then give preview. So we can these sections will automatically calculate the moment of inertia IXS, IYY and then IZZ. So you don't need to separately find out and put it into the real constant for the particular element, and then give the mesh view, and then you can see the meshing of the volume of the beam and then give OK and then on the screen you just right click and then give replot, and then go to next. We need to create a beam. So this is the construction of the beam. You need to create it into the Ansys user interface window. So go to modeling, go to create, and then go to key points. Here we have 4 key points. This is the origin 0, 1, 2, 3. At key point 1, 2, 3, there is a point load acting at different distance from the origin. This is, we need to convert all the units should be taken into SI units, that is mm, Newton mm per second. Okay. So this should be converted into mm, and this should be, if it is given as kilonewton, you need to convert it into Newton. Okay. Next, go to key point in active CS. Key point 1 location will be 0. At X will be 0. Y is it also automatically 0. We're going to construct the beam only in along X axis. So you don't need to mention the value in Y is and Z. And then give apply. So what is the second key point distance? It is 1500 meter away from the origin. 1500 mm away from the origin. Just give 1500. So you get the second key point. And what is the third key point? It is 2500 mm away from the origin. So we just mention as third key point and give the value as 2500, and then give apply. And what is the fourth key point location? It is located at 3000 mm away from the origin. Just give us 4 key point number and give the value as, sorry, it is 3000. I wrongly mentioned 4. It will be 3000. So give the value as 3000 and then give OK. So we created a key point, and then using the line command you can construct the line by connecting those key points. So go to lines and then straight line. So you can use the single pick of key point. So first select the first 0th key point, and then second key point, and then second key point, and then third key point, and then third key point, and then fourth key point, and then give OK. So you construct the beam. So next we need to discretize the beam into find 5 elements. So what is the element we previously selected? 2 node 198. Using the element we going to discretize the beam into find 5 elements for getting the bending moment analysis of the beam. So go to meshing, and then you can use many more options to discretize the beam. I use here as a mesh tool. It is a very most easy and easy tool to meshing the beam. So go to lines. I'm going to discretize this line. Go to lines and then set, and then give pick call. So or else you can single pick. Okay, pick 1, pick 2, pick 3. Or else you can give, pick all. Just give one click to the pick all, the entire beam will be selected, and then you can discretize into by specifying the element length or else number of element division. I require each and every portion of the beam divided into 10 elements, so I just give here 10.0 and then give OK. So next again choose the mesh tool. It will be hide backside of this screen. So again just click mesh tool. It will be again comes, and then you choose mesh and then give again pick all. So the total beam is mesh. So for viewing the mesh, go to plot and then multi-plot. So you can see meshing. You can see the discretization of the beam. Okay, you can see the discretization of the beam. By go to plot and then give lines, you can see the discretization of the beam. And then next we need to apply the loads, and then go to loads. This is the static analysis. You need to define the analysis type, static analysis, and then give OK. And then next we need to define the loads. For going to the define load, just open up the define loads and open up apply and open up structural. This is the structural analysis. I go for structural, and I need to set the displacement. So this is the cantilever beam. At cantilever beam, this point is, that is origin, is rigidly fixed and the remaining is freely oscillate. So just select the displacement, and here we have the nodes or its key point. We already created a key point for the individual location where the loads and then constraints occurs. So we can use the key point to define the define the constraint. So we can go on key points and then choose the first key point and then give OK. And this is the cantilever beam. All the displacement along X, Y, Z, that is all the degrees of freedom going to be arrested for cantilever beam. Give all degrees of freedom and then give OK. All the degrees of freedom got arrested. Next we going to define the point load. So there is 3-point load act at the three different key points. One is 1500 mm away from origin, another one is 2500 away from the origin, another one is 3000 mm away from the origin. The first one is 300 Newton and second one is 400 Newton and third one is the 500 Newton. And then you can go to this is the comes under the category of force or moment load. Go to force or moment load. You can apply the load at the respective key point. If you not create a key point, you can use the load and then apply it on the specific point on the beam and then go to on key point and then select the second key point. You can second, third and then fourth key point. I choose the second key point and then give apply, and this is the y direction load and then it will be acting downwards as per the center of material procedure. We need to give it as a minus value. What is the value of the load? Which is minus 300 Newton. Just give minus 300 Newton and then give apply. And then again next I need to apply the load on the third key point. Just select the third key point and then give apply. And what is the load value in y direction? Minus 400 Newton. Just give minus 400, then give minus 400 and then give apply. And then I next need to apply the another load which is 500 Newton at the last fourth key point. Just select the fourth key point and then give apply and then Fy and then load is minus 500 and then give OK. So we apply all the loads and we define all the constraint for the cantilever beam. Next we need to solve it for getting the results. Go to solution, go to solve, go to current ls and then give OK. The solution will be calculated. That is the deflection of the beam for the point load acting on the beam will be calculated. Give close and then give close. Next you need to see the shear force and then bending moment diagram. Okay, so how do I calculate this? How do I get the result of shear force and bending moment diagram? You need to get into the, so these are the steps. I will given the PPT in the link. You can find it from the PPT. I just for understanding purpose I give the number of element as 10. Therefore you can get the clear result of the beam. So that only I give 10 elements. So you can get the PPT, read out it by download the PPTs, and then we need to find out the shear force and then bending moment diagram. Just you need to go to the element table. In define table you need to add the element to find out the shear force and then bending moment diagram. That is the SMIC element of 3 and 6 generally used for bending moment. That is 3 and 6 and 3 and 16 generally used for bending moment and 6 and 19 generally used for shear force diagram. And then go to general post processor, go to element table, define table, add, and then go to by sequence number and then SMIC3 and then give apply. This element will be added and then next go to by sequence number, go to give the value as 6 and then give apply by, and then go to by sequence number and then give the SMIC value as 16 and then go to give apply and then go to by sequence number and the element is 19 and then give OK. So you can see the which are the elements used to find out shear force and then bending moment through the Ansys help. If you get into the help, you can get into the 2 node 188 beam element and then you can read out the helping content in that online. You can see 3, 6 and 18. 3, 6 and 19 are used to find out the element 3, 6, 19, 16 and 19 used to find out the shear force and then bending moment diagram and then give OK and then give close. And then next we need to first of all find out the deformation of the beam. So go to deformed shape and then give deform plus undeformed shape and then give OK. You can see the deformation of the beam for the point load acting on the beam. The maximum deflection is 0.090197 mm. This is the maximum deflection of the beam DMX. So go to, for saving the results, you can go to file, go to report generator, and then you can choose the folder where it need to be stored. Go to which directory it need to be stored. Go to directory and then choose my work file. I prefer my directory. I just prefer my directory where it need to be stored. Under Ansys file and my work file, I need to save it. Give OK, and then it's append and then give OK, and then choose the camera snap to save the result of the displacement. Give that camera. I click the camera icon and then give OK, and then you can change the name. Deflection of beam. Deflection of cantilever beam, and then give OK, and then give close. So and then next we need to see the shear force and then bending moment results. Okay, so go to the contour plot and then go to line element results. Choose 6 and 19 for bending moment, 3 and 16 for shear force diagram. 3 and 16 for 3 and 16 for bending moment, 6 and 19 for shear force diagram. So 3 and 16 for bending moment diagram, and then give OK. You can getting the bending moment diagram. So this is the bending moment diagram. This is the bending moment diagram of the cantilever beam 3 and 16. And then next go to element result and then 6 and sorry 3 and 16 you can get the bending moment diagram. 6 and 19 you can get the shear force diagram for the point load acting on the cantilever beam. This is the shear force diagram. You can get it from the element 6 and 19. Okay, so next we need to see the nodal solution of the each and every element for the degrees of freedom, degrees of freedom, and then displacement vector sum. Go to displacement vector sum. You can get the xy is a total displacement. So give OK. You can see the total displacement. So this is the maximum displacement. SMX and then DMX both are same. And then if you want to see the stress result, you can go to visualize by stress. For visualize the stress, you need to see it in the three-dimensional view. Okay, and then okay, you can save this result. Go to file, report generators, and then choose the location where it need to be stored, and then you can under the image folder it need to be saved. Okay, give OK, and then give OK. Okay, no, and then give OK, and then use take the image snaps, and then give the name of the result. So this is the displacement vector sum. Displacement vector sum result, and then give OK, and then close it. So you can visualize it to 3D, three-dimensional displacement of the beam. Go to plot control, go to style, size and shape, and enable the element shape display of elements. Give OK, and then give OK. You can see the three-dimensional of the beam, and then click the isometric view. You can see the displacement of the beam. Okay. So you can again report generator, and then you can use the same thing, and then give OK, and then image capture, and then give OK, and then whatever the name you can give it, then give close. So you can see the animation of the beam. Go to plot control, go to animation, go to see the deformed shape. Okay, and then give OK. Not need to change animation. Number of frames created is 10 frames. Time delay for each and every frame is 0.5 second. I want to see deform shape only, and then give OK. So this is the deformation of my cantilever beam, and then you stop. It automatically saved, and then you stop, and then you close. And then next go to plot control. Again I want to see the deformation of the deformed result of the displacement vector sum, deformed result, and the degrees of freedom solution. use sum, that is displacement vector sum, and then give OK. So we can see the displacement vector sum of the cantilever beam, and then give stop, then give close. So next we want to see the result, stress result. Go to stress and then choose the one with stress, and then give OK. So this is the minimum stress and this is the maximum stress. So at constrained region, that is key point 0, we get the maximum stress for the load act on the cantilever beam, that is 0.9533 Newton per mm square, and the minimum stress here acting, that is 0.19 into e to the power minus 18 Newton per mm square. They had the minimum stress acting. Okay, and then you can save the results, stress results. Go to report generator and then give OK and then give the snap icon, and then you can name it as a Canty stress result. Canty stress result. Then give OK. Give close. If you want to see the vector plot results, you can go to vector plot and then choose predefined vector and then degrees of freedom, that is translation use sum, and then give OK. You can get the vector results. You can suppress the three-dimensional view and then off it, and then again go to predefined vector and then choose OK. Then you can get the vector results for the bending of the beam, and then you can also get the stress result, principal stress, sorry. And then if you want to see the reaction force at the support, you can go to list results and then go to reaction solution, and then all all items, give OK, all structure force, and then give OK, all structure force, give OK. You can get the reaction support at key point 1, that is Fy, that is the reaction force. Fy is 1200. And then if you want to individually visualize all the element results, you can go to nodal solution and then go to degrees of freedom and then displacement vector sum and then give OK. So you can get the displacement of individual element of the beam along x, y, z. So we get deflection only in y and then little amount moment displacement in z. Okay. So total we have 31 elements, and then you can save it. File, save wherever you want to, you can save it. You can save it on your respective directory, degrees of freedom element result. Similarly, you can get the nodal solution result, or okay, you can save it as a PDF also. Whatever you record, the same thing you can save it. So if you save it as a .lic, you can open it via notepad and then close it. And then next, if you want to see the stress, go to stress and then go to one my stress and then give OK. Sorry. Okay, thank you all.